Page 145. So number 3 for blah. Does anyone need me to do number 3? Does anyone need me to do any part of number 4? Number 7?
Yeah, can you do 7, please?
7, no matter, yeah. Okay. Right, so number 7 reads, Camille asked for internet to be half yearly on her account if the bank offers an annual equivalent rate of 4%. Find correct to 4 significant figures the equivalent half yearly rate. Okay, so this is a yearly rate, annual equivalent rate. Okay, so we have to change that to a half yearly rate. Okay, so what you do is, right, you think of an amount of money. So I always pick €100, right? So if she invested €100 after 1 year, right, she'd have, Camille, I don't know, €104. Okay, so now I want the interest rate. Okay, so the final amount is equal to the principal times 1 plus I all to the power of time, right? So the final amount is €104. The principal is €100, right? 1 plus I is the interest rate, right? I'm looking for the half yearly interest rate, so this 4% doesn't count, right? Okay, and how many half years am I talking about? I just did 1 year, so that's 2 half years. Okay, so then that's 1 plus I to be squared equals 104 divided by 100. Okay, then get the square root of each side. Okay, so 1 plus I is equal to the square root of 104 over 100. So when you sort that out, you get 1 plus I is equal to square root of 104. And when you sort that out, you'll get 1.019803, etc. So that means I is equal to 0. When you bring over the 1, then it's 0.019803, and turn it back into a percentage. So multiply by 100, turn that back into a percentage, and they said give your answer correct to 4 significant figures. That means you write 4 numbers. Okay, so multiply that by 100, it's 1.9803 percent. 4 significant figures means I'm allowed to write 1, 2, 3, 4. That one I have to cut it off there, so it's 1.98%. 1.980% for the 4 significant figures. Is that alright? Okay, that's number 7.
Thanks.
Okay, the next one you had was, where's my diary gone? The next one you had was number 9. Does anyone need number 9 done?
Can you do the first one, please?
The first part of number 9, right? Yeah, no bother. Okay, 12,000 is invested for at an annual equivalent rate, so AER of 3.5%. Okay, find the value of the investment after 5 years and 3 months. Now, okay, you can do it one of 2 ways. You can change this annual equivalent rate to a monthly rate, okay, and then have the time in months, right? Then have the time in months, so that's one option. Or you can leave it as a yearly rate and write this as a decimal. So that's 5 years and 3 out of 12. So that's 5 1/4. So that's 5.25 years. Okay, so that'd be the shorter way to do it that way. So then the final amount is equal to the principal times 1 plus I all to the power of t. So we're looking for the final amount. The principal is 12,000. write 3.5% as a decimal, which is 0.035, and all to the power of 5.25. Okay, that's the shortest way to do it. You could change that to a monthly rate if you wanted, just in the like you did in question 4, change it to a monthly rate and then say this is 63 months. Okay, you get the same answer. Sorry.
Miss, how would you change it to a monthly rate?
Right, okay. So if it's 3.5% per year, right, you have to make up an amount. So you'd say at the start of the year I put in €100, at the end of the year I have €103.50. Okay, then final amount is equal to the principal times 1 plus I all to the power of time. Okay, so the time is going to be in months now. So at the end of the year I had 103.50. At the start of the year I had 100. I'm looking for the monthly interest rate and the time is in months, so it's 12 months because I just did 1 year. Okay, then that's 1 plus I to the power of 12 equals 103.50 divided by 100. Then I have to get rid of this power of 12, so that means get the 12th root of each side. Okay, so the 12th root and to the power of 12 cancel each other off. And over this side, I get the 12th root, so shift and that button, 12, 103.5 over 100 equals, and when I do that, I'll get 1.0028708. Bring over the 1, so that means, and it becomes a minus 1, so the interest rate is 0.00287. It'll do me. So that's your interest rate written as a decimal because that's the one you'll be using. And then you go back and you go, final amount is equal to the principal times 1 plus I to the power of time. So the final amount is equal to the principal. I think she put in 12,000. And it's 1 plus 0.00287. And the time is 5 years and 3 months, which is 5 12s are 63 months in total. So into the calculator with that then. Okay, so you get the exact same answer there as you would up there. Sometimes you have to go down the monthly rate route though. Okay, is that alright?
Yeah, thank you.
Anyone need any other bit of number 9 done? No. Right, you had number 10. Anyone for 10? You had number 11. Anyone for 11? And number 12. Anyone for 12? Okay, right. I'm moving on to depreciation because the depreciation formula is very similar to this formula, so we'll still be practicing these. Okay, right. Okay, so the next section is depreciation, right? Okay, so what is depreciation? Right, depreciation occurs when the final value of an asset is less than its present value, right? It basically means if I bought a car today for 10,000, right, okay, next year it'll only be worth 6,000, and the year after that it'll only be worth 4,000, and etc. It's going to go down in value. Anything you buy really loses value. If you buy a computer this year for €1,000, next year it'll probably be worth €100, right? Okay, so depreciation occurs when the final value of an asset is less than its present value. Okay, so it loses its value, right? Okay, there are two types of depreciation, straight line depreciation, reducing balance depreciation, which is the one we're interested in. Straight line depreciation means it uses a set value every year. So for example, it might you lose 500 euros every year. So you buy your car this year for 2,000, next year it's worth 1,500, the next year it's worth 1,000, the next year it's worth 500, the next year it's worth 0. So straight line depreciation is when it loses a set amount every year, and you'll be asked nothing about that because it's easy, it's too easy. So straight line depreciation is just using a set amount each year, so it'll lose 500 euros every year, or it'll lose 100 euros every year, or etc. Reducing balance depreciation, girls, is where it loses a certain percentage, right? So if I bought my car for 5,000 euros and it's going to use 10%, okay? So this year, 10% of 5,000 would be 500, so it's only worth 4,500 next year. Next year, it'll lose 10% of 4,500. So it'll lose 450 euros, so it'll only be worth 4,050 euros. The following year, it'll lose 10% of 4,050 euros. So it'll lose 10% of its value every year, okay? So it's like compound interest, okay, where you get the interest on what you have in the bank at the start of the year. You lose the amount you lose off the price is a certain percentage of its value at the start of the year, okay? And it's called reducing balance depreciation, and you'll see it's very similar to the compound interest formula, except there's a minus in there. So instead of earning interest, you're losing it, okay? So F is the final amount, P is the original value, right, okay? The principal, we called it, right, the original value of the car or the computer or whatever you're talking about. I is the interest rate written as a decimal, and T is the time in years if it's a yearly interest rate, okay? If they give you a monthly interest rate, it has to be in months, okay? The interest rate and the time have to correspond, okay? Are we good with that? Can I move on to the next one? Right, so this is your important thing, and just so you know, financial maths formulas are on page 30 of the log tables, okay? And the compound interest one is first, right? The compound interest one moved around is second, and the depreciation one is third, right? You don't need this one, right? Okay, and we'll need this one here, the amortization one, by the end of the chapter, okay? But that's it. So you have 4 formulas there, okay? So the first 3 and the amortization one on the next page, okay? Which we will get to, don't worry. Right, example 1, right? A new TV costs 1,400 euros. Assuming a depreciation rate of 8% per month, right? Find its value after 15 months, okay? So its rate is in the monthly rate and its time is in months, so we're fine, okay? So there's no need to change anything. So the final amount is how much it's worth now is equal to the principal, what it was worth at the start, 1 minus I, because it's depreciation, all to the power of t. Okay, so the final amount is what it's worth now. P is what it was worth at the start, which is 1,400. It's 1, take away the interest rate as a decimal, so 8% as a decimal is 0.08, and that's all to the power of 15. Okay, so into the calculator with that, that's 1,400, open bracket, 0.92, close bracket, to the power of 15 equals, right, 400.82 rounded to 2 places of decimals, because it's money. Even though they don't tell you 2 places of decimals, when it's money you round to 2 places of decimals. Okay, right, is that okay? That's just a straightforward filling out the formula. Right, okay, example 2 is over here. Are we ready? Can I take it away? Going, gone. So example 2. A creamery has a stock of 60,000 kilograms of dried milk powder. Okay, of dried milk powder at the end of January 2004. If the stock is reduced at a rate of 15% per month, find the dried milk stock to the nearest kilogram at the beginning of April 2005. So the dried stock is going down and down. Okay, that's depreciation. Okay, so we know we're on our final amount is equal to the principal times 1 minus I all to the power of t. So the final amount is what we're left with. Principal is what we started with. So we started with 60,000, right? And it's 1 minus the monthly rate is 15%, so that's 0.15. Now, I have to work out the time in months. So I have to work out how many months from the end of January, right, all the way up to the start of April. So the end of January to the start of April. So the end of January to the end of the year is 11 months, right? And then to the start of April is 3 months. So that's 14 months in total. Okay? And then into the calculator with that and press equals. Okay, I have to type in the wrong thing, sorry. Okay, and I still typed in the wrong thing. No, I didn't. Sorry. 6166.18, and they said to the nearest kilogram, so that's 6166 kilograms. Okay, that's just another straightforward one. The depreciation ones tend to be. Okay. Okay, ready? Can I go? Okay, no one's screaming at me. Example 3. So a company asset reduces, right? So it reduces depreciation in value from 175,000 to 73,187.09 at a depreciation rate of 16% per annum over t years, right? Find the value of t. So this time I'm missing t. So find amount is equal to the principal times 1 minus I to the power of t. So the final amount is what it's worth now. It's worth 73,187.09 now. Principal is what it was worth at the start, 175,000. And it's 1 minus the interest rate is 16%. So 16% as a decimal is 0.16. And I'm missing t. Okay. So this, when you're missing the power, you have to use logs. Okay. So that would be 1 minus 0.16 t equals 73,187.09 divided by 175,000. Okay, I might just turn that into a decimal just to make it easier to write. Okay, so you get 1 minus 0.16 t to the power of t equals, I'm going to turn that into a decimal, 173,187.09 divided by 175,000. 0.4182119. Now, when we're missing the power, we have to get the log of both sides. Which log do you use? Do you use log to the base 10, log to the base? You can use log to the base, whatever you want. Okay, I always tend to use ln. I don't know why, right? But you can use log as long as you do the same thing to both sides. It doesn't matter which one you use. So if you get the ln of both sides, right? Remember the rules of logs. You're allowed to bring the power down in front. So that's t times ln 1 minus t times 0.16 equals ln 0.4182119. Okay, and then if I divide each side by ln 1 minus 0.86, right, that's t is equal to ln 0.4182119 divided by ln of 1 minus 0.16. Okay, right, into the calculator with that. So we'll press ln of the answer equals divided by ln, that would be 0.84. And you get t is equal to 4.99999. So we'll call that 5, and it's in time, or it's in years, 5 years. Is that okay? Right, girls, I'm going to, that's the end of my examples on depreciation. So I'm going to give you a couple to do, right, okay, but then I'm going to ask you to come back, okay, because I'd like to start the next section. I'm going to do half the next section today as well. So I'm going to let you head off there for a minute, and I'm going to ask you to do page 147 to 148. Let's do numbers 1, 3 and 4. Okay, so, and if they're okay, we'll move on. Okay, so what you do is you can leave the meeting, go off and do 1, 3 and 4, and will you come back to me? It's, what time is it now? It's 9:15 now. Will you come back to me at 9:30, and I'm going to do the start of the next section as well. So head off there for 14 minutes, do those questions, and you can come back to the meeting. Right, okay?
Miss, would you be able to show me the start of the question, please?
I will, no bother.
Thank you.
Right, okay, so head off for 15 minutes, do these, and come back at 9:30. That's 107.
Thanks, Miss.
Yes? I can't hear you, say it louder please. Show you, which one? Example, I don't know, I can't hear you. I'm presuming it's not example 3, example 2? No? Send me a message in chat because your microphone isn't great. Okay. If you send me a message in chat, I'll be able to read it. Example 1. Right, okay. Now,
Thanks,
no bother.